So today we're going to be working on a two sample proportion confidence interval. And really, that you're going to see the same format that you guys have been seeing all chapter. Now it's just a matter of everything we do, we kind of have to do twice. So these can get pretty ugly looking, but we're nearing the end of the ugliness. So we're working on this problem today right here. We have these two pain medications, and they're given to two different groups of patients who have been complaining of a certain kind of joint pain. So they randomly divide these people into two groups and then administered the painkillers. So you're going to see here's group A. Notice of 112, 84 had pain relief. Of 108 people in the other group, 66 had pain relief. So notice this is a proportion. Every problem you've got to ask yourself now, is it a mean? Is it a proportion? Is it one sample? Is it two sample? Is it a confidence interval, or is it a significance test? So there's quite a few things that you've got to kind of work through. I can see that this is two sample because you can see the two samples right here. Hopefully it's obvious to you that it's a proportion because it's the number of successes out of the total. There's nothing here that says anything about averages or means. So this is definitely a proportion, and it will say, it's a confidence interval. It even says, please create a confidence interval. So now, I'm going to start out, and what has to be defined are your pi's. So you notice that pi A, this is the true population proportion of people who found pain relief for pain reliever A effective. Now notice this is not a significance test, so you don't know what each individual pi is. This is what we're trying to find. So we're just going to define it, as so, the two of them. Now the next variables down here, these are all coming from the samples. So I've got P hat A, this is for the pain relievers A, so 84 out of 112. Now notice I did not write the words because I don't have to. It's only the Greek letters that have to be defined. But this is the sample proportion, so let's even write that just so you guys can see. Sample proportion of people who found pain reliever A affected. This is the sample proportion of people who found pain reliever B effective. So you don't have to define that. Now there's going to be a new variable showing up, and it's going to happen whenever you have two samples that you're trying to compare to each other, and because everything's going to be about the differences. So you're going to notice I've got P hat A minus P hat B, and I'm taking 0.75 minus 0.61, and this is 0.14. This is the differences in the sample proportions. This is extremely important, that differences. That's what's going to show up as we proceed with the problem. The other thing that I just want to point out is you can subtract either way. You can take 0.61 minus 0.75. I like to do larger proportion minus smaller proportion so that I'm dealing with positive numbers. But if you did it, you'd get the same answer. You just would have some negative numbers because you did B minus A. So notice I said the way that we were subtracting right here. Okay. So moving on, I'm going to go down here, and we have our title. I also, I might want to add here, N is 112, NA, and NB is 108. Just to keep that's a variable I'll have to throw in there. Conditions for a two sample proportion 95% confidence interval. Okay, title, very important, explains what you're doing. So now, number one, we would normally be in the mindset of simple random sample, okay, from the population. And now, in this situation, though, we were not sampling. In fact, these are patients who have just, been complaining of a certain joint pain. So this experiment is working with what they have. So normally what you would have to do, if it was, randomly selected, you would have to write, like, Number 1, simple random sample from the population of these people. Simple random sample from the population of these people. But in this situation, this is actually not a sample at all. So what we're going to point out is that it's an experiment. So we need the two groups to be independent of each other. So since the data came from two groups in a randomized experiment, this is the key. There wasn't random selection. Two groups can be viewed as independent. Okay? Now the second condition, you guys hopefully at this point in time are thinking population greater than 10n, but we only do that when you're sampling without replacement, and this is not even a sampling problem. So the second condition, the first condition worries about the two different groups being independent. The second condition is the people within the group. So you'll notice, okay, so you can say something along the lines of the people in each group should be independent. Knowing whether one subject has found relief gives no information about whether another one does. So the first one is going to talk about, the two different groups being independent of each other. The second is within the groups. So now I can come down here, do my therefore. We have independent patients, and that's coming from, number 1 and number 2 together. Okay, so now I get to the third condition. I am on a proportion. I am on a proportion. So we have to be thinking, okay, what do we normally do with proportions? Please do not use the central limit theorem of any kind. Don't do anything like that. This goes back to your n times pi and n times 1 minus pi. The problem here is you do not have pi. So we're going to use the next best thing, which is the p hat. But you also have to check, because what you really have are two different distributions coming together. So, like I said, you're kind of just doubling up on everything that you've done before. So you'll see this beautiful stuff going on here. Okay, so n p hat is greater than or equal to 10. N 1 minus p hat is greater than or equal to 10. And then I have to go and check the n, the sample B, or the group B. So I'm doing NB times P hat B is greater than or equal to 10. NB and 1 minus P hat B is greater than or equal to 10. So do you guys see, it's the same thing as before, you just have to do it twice. So if this is working, and what this is checking is that you've got a normal curve here, you have a normal curve here, and what we're going to do is bring these two distributions together onto one normal curve that's all about the differences. So we are therefore okay for a normal approximation. So I'm going to draw my curve. And remember, it's all about the differences. And so you're going to notice I don't have any pi's, so I can't put that in the middle of the curve. And I have these two individual samples. So the way that we bring these two samples together is looking at the differences. This is going to be in the middle of the curve. And let me also point out, here I am, page 5, because this is really going to be important. Sorry, this is a grape sheet. I don't mean to offend you guys. So notice what's going to happen is, in a confidence interval, you take the statistic, there's two of them, plus or minus the critical value times the standard deviation of the statistic. So the statistic is going to be the two p hats that are subtracted. Your critical value is your z star, and now we need the standard deviation of the statistic. Well, normally you would go down here, right, for single samples, but you guys are no longer in a single sample, so now we're coming down here to the difference of sample proportions. When you have two samples, see it? Okay, keep this in mind, and it even says on your lime sheet, difference of sample means difference of sample proportions. The only way to compare two samples to each other is to look at the differences. So we're going to come here, and you guys see this? difference in sample proportions. This is the formula. It's ugly looking, but you don't have to memorize it because it's right here. You just have to know where to look. This is, remember your p's are pi's, but in this situation we don't have pi's, so the next best thing is to use the p hats. So we're going to be using p hats in both of these. P hat A, p hat B. Okay, so I go to the curve, and the middle of the curve is going to be the difference in sample proportions right here. We had p hat A minus p hat B. Your job is to add and subtract, hence the plus or minus, and figure out what those numbers are so that we can report an interval for the differences between these two groups. Okay, so here's the formula, okay? So look at it nicely. Okay. Difference in sample proportions, this is your statistic, plus or minus the critical value, that's your z star if I'm on a proportion problem, times the square root of p hat A times 1 minus p hat A over n of A. See, I'm just doing it with both of them, and I'm plugging them into that two sample formula. And p hat B, 1 minus p hat B over n of B. So I take this as, again, this is the middle of your curve. With confidence intervals, you always start in the middle, add and subtract. Now, where did the 1.96 come from? If it's been a while. If you're on a proportion problem, at the bottom of page 15, what did we say we were doing? 95%. So that's where we get the 1.960 right here. Just go one above because it's a proportion. If it was a mean t distribution, you'd go up there, but we're just looking here. So 1.96. Okay, so formula, substitution, and now we go to the calculator. So where are we going to go? Stat test. Sorry, you can't see that. No, we're not on a test, so let's go down to the intervals. Okay, so I'm on a 2 prop. If you're on a proportion problem, they will use the word prop in there. So this is a 2 prop z interval. Now, the calculator does not know how you subtracted. Your calculator will always take x1, n1 minus x2, n2. So you need to make sure that you enter these the way you want the calculators to subtract them. So when I go all the way up at the top, okay, to my p hat A and my p hat B, I did A minus B because A just so happened to be larger. So this is the first proportion that I'm going to enter in because that's how I want it to subtract. So 84 out of 112 and 66 out of 108. We're doing a 95% confidence interval. You're going to hit calculate and it's going to spit out your confidence interval. So it looks like we've got between 1% and 3% difference in the amount of people who are finding the medication effective. So I come down here, copy those numbers down, and we interpret the confidence interval. We are 95% confidence. The difference in the population proportion of people who find these medications effective is between 0.017 and 0.261. So if I go up here, I'm using the same lingo that they used in the end. Do you see how it says, find a 95% confidence interval for the difference in the proportions of people who may find these medications effective? So here we are with our interval. Now I guess my question to you is, based on what you see in that interval, was one medication more effective than the other? Give you a second to think about it, and hopefully you're seeing that these are coming from differences. And do you guys notice how 0 is not in the interval? And if 0 was in the interval, you'd have p hat A minus p hat b. And if they both equal 0, that would mean that they actually had the same amount of effectiveness. But because we are always positive, and 0 is not in the interval, I can say that there was a higher proportion of people who took pain reliever A that was affected versus the people who took pain reliever B effective. So you can turn this into a significance test where, is there a difference between these two things? And that's what we'll be working on tomorrow, because this is a confidence interval. It can relate to a two-sided test. So there you guys go. That is a 2-sample proportion confidence interval. We'll be looking at 2-sample proportion significance test, where you will be pulling your P's, and we'll talk about that in the next video. Have a good day, guys.